Hey everyone, welcome back to DataCraft, your go-to place for all data engineering things. If you are new here, don't forget to hit that subscribe button and click the bell icon to stay updated with our latest videos. So today, let's get into key concepts of data engineering. In today's video, we are diving into the fundamental concept of data engineering. Whether you are a beginner or looking to brush up on your skills, this video will give you a solid understanding of basics. Hope so, you will be enjoying it. First up, we have ETL, which stands for Extract, Transform, Load. This process involves extracting data from various sources, transforming it into a suitable format, and loading it into a destination system. To illustrate, imagine you are working in sales data from an e-commerce platform. You would start by extracting the raw sales data from the platform's database, as well as from your other systems like CRM, ERP. Next, you would transform this data by aggregating daily sales figure, cleaning up any inconsistencies, and formatting it appropriately. Finally, you would load the processed data into data warehouse, where it can be accessed for reporting and analysis. This is a classic ETL process. Let's talk about ELT, which stands for Extract, Load, Transform. Unlike ETL, in ELT, the extracted data is immediately loaded into a destination system, such as data lakes. This step involves transferring the raw data into its original form to data lakes and then transformed as needed for analysis. Modern cloud-based data lakes are designed to handle large volumes of raw data efficiently, making this approach feasible nowadays. To illustrate, imagine you are working with sales data for e-commerce platform like Amazon. You would start by extracting the raw sales data from the platform's database, as well as from your CRM and ERP systems. Next, you would load them as a raw data directly into the data lake. Finally, you would transform the data within the data lake by aggregating daily sales figure, and cleaning up any inconsistencies, and formatting it appropriately. Moving on to data pipelines. A data pipeline is a series of data processing steps that automate the movement and transformation of data from source to destination. This process is essential for ensuring that data flows smoothly and efficiently through an organization system. For example, imagine a data pipeline that collects log data from web servers. The pipeline would start by collecting the log data from multiple servers. Next, it would ingest this data into a processing environment. The processing step would then extract useful metrics such as page views and error rates from the raw log data. After processing, the metrics would be stored in a database. Finally, the stored data would be available for access and analysis by data analysts to monitor website performance and identify some issues. Moving on to components of data pipeline, it consists of ingestion, processing, and storage. Ingestion is a first step in a data pipeline where raw data is collected from various sources. These sources can include a database or an APIs or IoT devices or web servers and more. The goal of ingestion is to gather all relevant data that will be used for further processing. This step can be performed in real time where data is continuously collected as it is generated, or like batches where data is collected at specific intervals of time. Moving on to processing, once data is ingested, it moves on to a processing stage. This involves transforming and enriching the data to make it suitable for analysis. Transformation can include tasks such as cleaning the data to remove errors and inconsistencies, filtering out irrelevant information, aggregating the data to summarize it. Enrichment involves adding additional context or information to data, makes it more valuable for analysis. For example, raw sales data might be processed to calculate total sales per day, to identify the trends and highlight the anomalies. The final component of data pipeline is storage. After data has been processed, it needs to be stored in a suitable format for analysis. This could be a database, data warehouse, or a data lake. The choice of storage depends on type of data and how it has to be used. The stored data is then made available for querying and analysis by data analysts, data scientists, and business intelligence tools. Now let's talk about data warehousing, data marts, and data lakes. A data warehouse is a centralized repository for storing large volumes of structured data from multiple sources. For example, a retail company might use data warehouse to consolidate sales, inventory, and customer data for analysis. While data marts, on the other hand, are a subset of data warehouse tailored for a specific business lines. For instance, marketing data mart might focus on customers' demographics and campaign performance, while data lakes are designed to store vast amount of raw data in its native format until it is needed for analysis. An example would be storing raw sensor data from an IoT device in a cloud-based data lake, which can then be processed and analyzed as needed for the business. Data warehousing offers several benefits. It integrates data from different sources into a single repository, optimizes query performance and reporting, and stores historical data for trend analysis and forecasting. There are also other important concepts in data engineering. Data governance involves policies and procedures for managing data assets, ensuring data quality, privacy, and security. Big data technologies like Hadoop and Spark handle large-scale data processing. Cloud data engineering utilizes platforms like AWS, Azure, and Google Cloud for scalable and flexible data solutions. To conclude, the key concepts of data engineering include ETL, ELT, data pipelines, data warehousing, data marts, data lakes, and other essential practices. Mastering this concept is essential for effective data management and analysis. If you found this video helpful, give it a thumbs up and share it with your friends. And don't forget to subscribe for more contents like this. Thanks for watching, and I will see you in the next video. Thank you all.